1 ton of waste paper enters this mill every 90 seconds. 12 minutes later, it leaves as a 2.5-meter wide finished roll. Here's how waste paper becomes a uniform sheet in a fully controlled 12-minute loop. Let's step inside the line. This mill runs non-stop and recycles over 200 tons per day. Ink, plastics, and adhesives must be removed without breaking the fibers. Moisture and chemistry operate inside narrow tolerance windows. Every sheet you use at home or work begins in a place like this. Baled paper arrives in 1-ton blocks. A conveyor feeds each bale into a 15,000-liter pulper at 50 degrees Celsius. Inside, blades spin at 400 RPM. They break the material into fibers and create a slurry with 4 to 6% consistency. A density sensor tracks slurry thickness. If consistency rises above 6%, water valves open. If temperature drops below 48 degrees Celsius, steam injects automatically. Process identity. The pulper defines fiber quality for the entire line. Breaking the paper apart is only the beginning. Ink still needs to be removed. The slurry enters flotation cells. Air injects at 2 bar through fine diffusers. Ink particles attach to bubbles and rise to the surface. A skimmer removes foam every 15 seconds. Temperature holds near 45 degrees Celsius to stabilize chemistry. If it slips below 42 degrees Celsius, steam engages within seconds. This stage removes up to 95% of ink and toner. Environmental insight. Every ton recovered here replaces new wood pulp. Ink is gone. Now the system must separate contaminants from usable fibers. The slurry flows through pressure screens with 0.15 millimeter slots. Plastics, staples, and adhesive clumps are rejected. Flow rate sits at 800 liters per minute. A pressure sensor detects clogging. If pressure drop exceeds 1.2 bar, backflush jets clear the screen. Hydrocyclones apply centrifugal force. Heavy particles exit the bottom. Clean fibers move forward at 1.5% consistency. Mixed waste becomes a uniform fiber stream in minutes. But fibers can't form a sheet yet. They must be thickened. Vacuum filters remove water at negative 0.6 bar. Consistency rises from 1.5% to 4% in under 90 seconds. The slurry moves into the head box. It spreads across a 3.2-meter forming screen. Flow holds within plus or minus 2%. 16 ultrasonic sensors monitor distribution. If deviation exceeds 3%, the slice adjusts by 0.1 millimeters. Process identity. The head box defines sheet uniformity long before pressing or drying. Now the sheet begins to form. The slurry lands on a moving wire at 600 meters per minute. Gravity and vacuum boxes remove water. After 4 seconds, dryness reaches 20%. Pressing follows. 2 steel rollers apply 5,000 kilonewtons. Dryness rises to 45%. Then the dryer section begins. 40 cylinders heat the sheet at 120 to 150 degrees Celsius. Contact time per cylinder is under 1 second. Infrared sensors scan every 10 centimeters. Target dryness is 92 to 94%. If any zone exceeds 95%, steam flow reduces instantly. Every notebook page starts its life in conditions like this. But the sheet still needs its final structure. The sheet enters the calendar stack. Rollers apply 3,000 kilonewtons to smooth the surface. Target thickness is 80 microns. Tolerance is plus or minus 3 microns. Laser sensors measure thickness at 32 points. If variation appears, hydraulic actuators adjust the roller gap in 0.2 seconds. The sheet winds into an 8-ton jumbo roll. A slitter rewinds it into smaller rolls for shipment. One more step completes the transformation. Process identity, closed-loop control. Chemistry, temperature, and flow are corrected every few seconds. Consistency sensors adjust dilution water in real time. Flotation heaters stabilize chemistry within a 3 degrees Celsius band. Pressure screens respond to clogging in under 1 second. Dryer steam valves correct moisture drift instantly. Calendar actuators track thickness and respond within 0.2 seconds. Every cycle of feedback keeps fibers stable through the entire 12-minute loop. From bale to finished roll in 12 minutes. A continuous, automated line. Every mechanism monitored, corrected, and stabilized. This is how 200 tons of old paper become new sheets every day. If you want the cardboard version of this process, with even tighter moisture control, let me know in the comments.